Hey, welcome back to the bench. Good to see you all again. Hope you're all well. Thanks for joining the channel. So today on the bench I have a Dual 604. This is brought to me by the client, same client that brought me the Yamaha integrated amp, and he asked me just to check it over, give it a service. I don't know if there's anything, I don't think there's anything wrong with it. He didn't say there was. He just wanted it checked over, and I believe he asked for new cables on the phono. So let's have a look at this. This is a nice turntable. It is very nice condition. Looks like it's probably a daily driver. What has it got on it? It's got a Pickering XV15 cartridge on it. It's gold plated. It's nice Pickering cartridge. You can see it here. Very nice. It's got the brush that drops down. Let's have a look at the stylus. Maybe there's... Yeah, it's very dirty. I'm going to have to clean it because I can't really tell anything on the stylus right now. So, let's put that aside so it doesn't get damaged. But the rest of this, we're going to service. I don't know if... Probably just give the motor a relubrication, and we'll go in and we'll check the capacitors and electronic circuits. Not much else to do here. I'm pretty sure that everything is good. It's all set up for 2 grams tracking force. Everything's nice and tight. And we'll do the service the pots and switches as well and give it a clean. This one has very dirty mat, so we'll give that a scrub and have that coming out looking good. It's got the adhesive on there. Let's pull this off. It's got a nice platter. Etched on the outside is the strobe marks for the strobe light. So I think this is a automatic return. I think that's all it is. It's just an automatic return, and I think if I click it, it will just automatically return for us. Yes, that seems to be working. Everything's fine. So yeah, it might be a short video. See some scratches around the outside here from the platter. Usually that happens if somebody presses on the platter while it's rotating, and then it touches and it scratches. So let's have a good look at this. I was just looking at this platter. Some strange things jumped out at me. So I don't know if this is by design or what, but it says made in Quermany. You can see that it's a Q. That's weird. And then they have these holes, 12 of these holes, and they're all numbered 1, 2, 3, but 3 is backwards, as you can see. There's 2, and then 3 is upside down, and then 4. So I don't know if somebody screwed up there. Everything else is the right side up, even the 8 is the right way up. But they put, so when they factory balance these, they have these holes, 12 of these holes, and then they factory balance it. They must spin it, and these 2 have lead weights installed. It looks like they're crimped in there, or pressed in. You probably wouldn't get those out unless you picked at them and drilled them. But those are definitely lead because I scratched it with my fingernail. But it's kind of interesting. It's nice. Dual did a lot of precision machining on this to make a nice end product. It's nice casting too. Made in Quermany. So getting into it, you look at the bottom and there is no screws. It's just the bottom is stapled onto the wooden base. Okay, so that's not how we're getting in. There is a plate here. Let's look at the back. There is a plate here with 2 screws that disconnects the cables from the bottom. And yeah, so we have to go in through the top. And there are 3 suspension points, 1, 2, and 3. And what we do is you just back these off until these are loose, and then you flip it in like that, because there's at the bottom there's a catch that hooks on the, so just hook it like this and lift it up, and then you can see the catch on the bottom here. It's a washer. Just let that sit for now. And we'll do the other side. Tip it in and lift. Okay, that's 2. Here's the 3rd one. Tip it this way, and it should come right off. And there we are. So let's put this down. I should have taken those screws out to begin with, but let's put this down for now, and I'll take those screws out. Should be able to feed the cord through that hole. There we go. And we're separate. I can clean all the dust out of the bottom of this thing. Let's have a look. Nice chunky motor. A little electronic circuit. Looks like it's got original caps in it. We'll check if any of those are bad. I don't think they will be, but we'll just check that. And this is a transformer, I believe. Yeah, transformer. This one goes out to the strobe light. There is a neon bulb strobe, it looks like. And then our potentiometer and our switches up here. So this would be a pretty basic service. I'm not going to go through and redo everything, because everything looks great as far as condition. Looks like it's well cared for. I'm going to get rid of this base. Okay, I think what I want to do first is I want to get rid of these old caps and just put some new ones in. There's just 4 on this board. And then in the power supply there's a few more. But let's get rid of these ones first. I think they've had a long, lustrous life, and they're going to get replaced. Because some of these plastic cap ones, I don't know if I have much faith in those ones. Okay, so that's free. Have a look at the back side of the board. Everything looks kind of good. Everything looks okay. There's no cracks. I don't see any cracks immediately. So let's pull out some of these and test them and see what they say. This is 220 at 6.3 volts. And that one should read about 600 milliohms. Let's see what I got here. So it's not bad. 243 microfarad, 120 milliohms. I think we'll just replace it anyway. We'll get new ones in. Yeah, there's just 4 of them here. A couple of tantalums. I'm not going to touch the tantalums because they're not a problem right now. If they were a problem, I'd replace them. Some people replace tantalums just because they're old and they don't trust them, but tantalums are really stable caps. They're not wet electrolyte like electrolytics. They're dry electrolyte, and they don't fail unless they experience an overvoltage or a voltage spike or something that stresses them beyond their capability. So we'll just leave those tantalums alone. Okay. All right. So I got a brand new 220 at 6.3. And this is a Rubicon ZLH for all those that are counting. There you go. Had some people triggered over my comments about Chinese caps. I'm not gonna comment anymore about capacitors because it seems some people take it really personally. But people seem to forget that it's just a capacitor and it's in the circuit to do a job. And that's about it. That's all I'm going to say. Okay, now there's one. A couple of 47s at 25. We'll do these 2 next. These are the ones that concern me because they are those plastic bodied electrolytics. ROE. These ones have a plastic body. They're marked on the top. Manufacturer is ROE, and they see a little ROE there at the bottom with the box around it. And the bottom has epoxy filled. So if they don't crack, I've seen these swell up and the top has little fractures in it from it swelling up, and I think that's probably when they're done. These ones look okay. This is a positive, negative. Let's see what this one measures. Wow, look at this. Hang on. 47 at 25 should be about 1.2, and I come back at 47 at 1.6 ohms. A little bit tired. I'll check this one again, if I got that right. Got the wrong setting on the... Yeah. Okay. One more here. Let's remove this one. Okay. I'm going to have one of those days today, I think. This is the same value. This one's domed on the top, and it looks like it's pressure buildup. Positive, negative. This one tests out at 44 and 3.2. So this one's probably, it's out of tolerance for one thing, but it's twice the ESR of the other one. So this one's failed. Definitely failed. And then let's get 2 new ones. The replacements are Rubicons, and these are YXMs. For those that are keeping score here. I know there are some keeping score, so keep them happy. It's amazing what some people get all worked up over. Where did my solder braid go? Oh, right here. Okay. All right. Positive is a long lead. The word is marked for positive, and the short lead is negative. Same on the LEDs. If you look at an LED, the long lead is your positive. Where did the other one go? Oh, right here, under my thumb. This one's not marked. Why? There's no marking on the board, so I'm going to check the owner's or the service manual on this one because I don't want to install it backwards. So let me bring it back. Okay, I checked the manual, and positive is towards the edge of the board, which I already have correct, so I'll put that back in. I don't know if you notice some manufacturers do that. They'll put all their electrolytics in a certain orientation facing one direction so that all the negatives are facing one side of the board. And I've seen a lot of manufacturers do that, and it's kind of nice because it, you know, if you're doing a cap replacement and you overlook the board and you see this happening, then you can rest assured all your caps are going to go in the right way if you just follow their plan. I've seen that on quite a few manufacturers actually. They orientate all their electrolytics to point the same direction. So these two. I think we got one more left. It's a 10 microfarad, I think it is. Let's see here. Okay. All right, last one is here. Positive down. It's 10 microfarad, 16 volt. Come on. IT&T. Well, they made capacitors, I guess. This one measures 11.2 microfarad at 15.3 ohms ESR, which is not very good. Let's get a new cap in there. Our new cap measures 9.9 microfarads and 6 ohms ESR. Considerably better. Positive down. Okay, that'll take care of this board. I'll give it a flux clean, and then I'll give it an inspection with the magnifying lens, touch up any dodgy solder joints, and then that'll be it for this. If there's anything else to do on here, that's it. Alright, next I'm going to look at the power supply, which is in this box. There's a transformer and rectifier, capacitor, filter. And here is a fuse. Yeah, we have a problem. We got a reefa cap here that is swollen and needs to go. Anytime you see a reefa cap, take it out, replace it. And there's a big electrolytic here. I don't know. You could probably test it in circuit. That reefer cap definitely has to go. So let's get this board out of here. How does this work? Is this part of a rubber isolated mount? I gotta remove the box first. That's got to happen. So I'm going to flip this back over, remove one of the two screws, and it should disconnect. 63 milliamp. Look at those Germans. They're so, I don't know, they sure love their precision. 63 milliamp fuse. Okay, now that I have the mounting screws for the box removed, I can flip it over, remove the 4 mounting screws from the transformer, and the transformer is free. I can lift it up and slide everything back and just roll it over, and we've got full access. So let's see here. This here is all primary. And by the way, if you can see this, this is your tap for your different multi-voltages. So you got 220 on this side, you got 110 on this side. So if you wanted to switch this from one region to the other, you could just move that wire from one tap to the other, and that would change your voltage. The transformer is set up to do both. So here's the 110, here's the common 110 and 220. So they're just using half the winding instead of the full winding. So let's take this bum capacitor out and have a look at it. Iron sits idling for so long that it's all dirty. Let's see here. Wire's in the way. I'm gonna have to use my wick on this. So I can't pull on it. There we go. Come on. Folded the leads over flush to the board. That's why it's so difficult to pull it out. But we got it. All right. So that looks like it's failed. Needs to be replaced. See the cracks in it? I don't know if you can see the cracks in it. Let's have a closer look at this. All right. These are the famous reefer caps, because they're called reefer caps because of the brand name. You can see it, it says reefer right here, and you can see the damage to this thing, the cracks here. It's a crack here, here, here. There's a big crack along this side, and it goes up like that, and there's cracks on this side. Across the top there's a crack. There's cracks here all radiating out, and this is already starting to peel off, fall off. See this? And that is, so what happens is moisture gets in these things and the cap starts to swell, and this is where you're getting all these cracks. And as it cracks, it allows more opportunity for air to get in, or oxygen or moisture, and it starts to accelerate. Eventually this will short, and since it's across the line, these have known to go up in flames, fill up rooms with smoke, and do all kinds of nasty things. So every time you see one of these reefer caps with this transparent kind of yellow housing, get rid of it, because it's garbage. Here's a look at the cap on the tester. It's 68 nanofarads. It's gone up in value. I think that's because it's got leakage. It says ESR 1.4 kilo ohms. Let me see if we have any DC resistance. It's saying we got about 20 some meg of ohms of leakage. Let me test it on my other tester. So here's a capacitance leakage tester. So let's set this up. We got it. Let's do 250 volts. Let's connect our capacitor. Let's turn up the current. Yeah, it is leaking. It's leaking about 15 microamps. So that cap is bad. Okay, I didn't have a 47 nanofarad safety cap, so I had 100. I replaced it with 100. It's not that big of a deal. It's adequate size. So that cap's been replaced. You can see it's a nice white one now. I still want to check this electrolytic. It's supposed to be 1,000. Let's see what we have here. If I can clip onto it. And we got 1,039 microfarads and 74 milliohms. That's not bad. I'm just going to leave that cap alone. I think that cap is fine. If I wanted to replace it, I'd have to put an axial cap in. No, hang on. I can just do... it right here. Positive and negative right there. What do you think about that? 16 volt, no 40 volt, 1,000 microfarad. I wonder what voltage this runs at. Might have to plug it in and test it. Alright, so I did replace this capacitor, even though there's nothing wrong with it. It was a 40 volt, 1,000 microfarad. I replaced it with a 35 volt, 1,000 mic. Now I did go and check the schematic, and apparently this power supply puts out about 20 volts, so my choice would be more than adequate. Now its backside has been cleaned and defluxed and checked. We're going to put this all back together now because we're done with the power supply and we're done with pretty much the electronics of this. We need to work on pots and switches now. Let's see if we can got to line this up. Line these up. I'll do that in a bit here. So I'll put this all back together and then we'll come back on the pot and switch. Achtung, nicht Eulen. So they don't want you servicing this motor. Now I looked in the service manual and they really don't talk about this motor, this EDS 500. All they want you to do is replace it. They say it's got sinter bearings, it's lubricated at the factory and shouldn't have to touch it for the life of the turntable. They said servicing this motor you need special tools and measurement devices. Now I don't know what that means. But looking at this, I can see the end cap is staked on with 4 crimps on the side, and that locks the cap in place. So to unlock this, to remove the motor, it's easy. You unsolder 4 wires, but you remove the motor, and you have the motor on your bench. How do you open it? You have to bang back these 4 peen marks and remove that cap, and then they start talking about special tools for measurement. And I'm not gonna touch this motor. This motor spins very well on its own. I doing the spin by hand, and it's got no issues whatsoever. It's not dried up. It's not sticky. So I'm just going to leave this motor alone, because I don't think opening up is going to benefit us at all. There's really nothing to do to it if it's lubricated fine already. I can also see that this has got 3 rivets on top. So once you take this end cap off, you're going to have more issues. Either you have to grind off rivets and replace them with screws, or do something else. This end cap's also riveted on, so they didn't intend this motor to be serviceable. And they're putting stickers on it, attention stickers, and even in the service manual, there's no information on servicing this motor. So we're just going to leave it alone. So Dual is using a 63 milliamp slow blow fuse, 250 volt fuse, and it's kind of a real oddball. So replacement fuses available in Canada from all these sources: Vancouver, Ontario, and Quebec. So here's that info if you need it. So one thing I didn't mention is that refit cap that I replaced. If that cap goes bad, this 63 milliamp is probably going to protect everything from a big smoke show and spark fire and kabang. So you got a 63 milliamp fuse. It's probably going to pop way before any of this drama happens. So yeah, you got to get that cap replaced for one thing. That's the first thing you need to do. And then if you have a problem finding this 63 milliamp fuse, there's your info. Alright, one of the last things I'm going to do is I'm going to replace the phono cables. The owner supplied me with a pair of gold-plated connectors on the one end, and braided connectors, braided wire. This is about a foot shorter than the originals, but I'll cut one end off and we'll attach this, and we'll eliminate these stock ones. I don't know, the stock ones are fine. They're probably fine with regards to how they work. The only problem is if you get a broken connection in here from flexing or whatever, sometimes they need to be replaced. But so what I'm going to do is remove the old ones. Let me get my got that out of the way. The problem is I won't be able to get strain relief on here because of the there's no way to get the strain relief on these two with this hole. But we can do other things. So let's remove this clamp screw. Okay, take off this shielded cover, and there's all our connections underneath. So these two on the outside here are grounds, these two on the inside are right and left signal, and my plan is to hack off the ends, solder them on, and then I'm going to use a clamp here on this. You have to create a clamp for clamping those wires down so that they're secure and they can't get pulled off, and they've got strain relief, and then they'll just flow through the back hole like that without any strain relief here. So let's get these prepped and ready, and these just pull off, I believe. Yeah. Another thing I noticed, there's no ground cable, so I'm going to add a ground cable. And they do specify in the service manual that the ground cable should be connected to the center ground connection here. What is going on here? This black wire here, that would be my ground connection. So that's where I can tie that into. And then I can run it out the back as well. Alright, so I finished this mod. I hacked the ends off this cord. and soldered them directly to the switch connections. This muting switch here is controlled by a cam, I guess, and it mutes the signal going out to the amplifier when it's not playing. So just everything's secured. I added a ground wire with a lug on the end. You can see that. The lug on the end. It's just so it's tied to the amplifier. So this all go out here, out this back hole, and it's going to stay like that. Now, what I did is I cut a little aluminum block and cut a couple of channels in it to provide relief, so that when I torque it down, it's not crushing the cable, but it's more like clamping it. And that's pretty solid. That's not going anywhere. That's a good strain relief. And you ain't all night all day, and it's not going to let these connections fail. So that's all done for this. So let's put the base back. Put this back in the base, and focus our attention somewhere else right now. All right, we're back together in the base, and tighten down the shipping screws so everything's tight. Now I did this pitch control. I treated the pot with fader, deoxit fader lube. What is it? It's the F100 stuff. Fader, yeah. And I treated the switch with the red deoxit, the D100, right on the contacts, just a little tiny micro drop. And that's all it needs. Work it in, and that switch will be good for a long, long time. Okay, so we're done with this base as far as I'm going to do. We're ready for testing. And, oops, some greasy fingers. I have to do cleanup too, because I got fingerprint smudges all over it. It was a nice pristine unit when it came in. Now it's all dirty with my hands. But let's put the platter back on. Let's test the speed regulation. And then we'll still haven't cleaned that platter. Okay, let's plug it in. Now I can't see anything with this light. Turn this light off. I'm going to focus in on the strobe light. Okay. So we're going for the bottom one. You can see our adjustment range. The pot seems clean, there's no twitchiness, everything's smooth and it holds steady. Okay, let's try 45. And that's holding good too. No problems there. I think that neon is working great, it's nice and bright. So we're going to leave it at that. And our range of adjustment is good. Very, very good. Pleased with this. Okay, now let's have a look at this cartridge. I had a look at the lens and I couldn't really see anything that was, the lens is quite, or the stylus is quite dirty. Here we go. Can't really see. It's all crusty and stuff. So let's give it a little bit of a clean. We'll have a look and see if we can tell if this stylus is okay. Looks like it's got corrosion on it. using alcohol on it. He's very, very gingerly touching the tip. You just don't want anything to get bent or... Yeah, that's odd the way it's all crusty looking, that cantilever. Give it a bit of a rub. Doesn't really take anything off. Okay, let's see if we can look at this sideways. Okay, that's looking not too bad. Still dirty. Still really dirty. Okay, let's try this side. Okay, looks like a conical tip. And it looks intact. It looks everything's okay. It's just really dirty. Clean some more on the tip. Yeah, that's good. I think it's got a good stylus. I don't see any big chips or anything taken out of it. Yeah, I think it's fine. This side looks really good. Looks like a diamond. Okay. Good enough. Okay, well there it is. It's working. It's back together. I tested the lead out sequence, so when it hits the right spot, it picks up, returns home, shuts off. Everything working good there. Nothing else to do. It was already set up. I'm not going to touch anything there. I'm just going to leave it alone. Everything looks good. So, I'm going to wrap this one up. Thanks for watching. Take care, and we'll see you on the next one.